All right. Getting more people. All right. Well, does anybody have any questions before we get started? Guys doing good? All right.
So for the deviation tables, I think you mentioned last week that some boats like have one prepared, or like the captains of the boats prepare them.
Yes.
Okay. Like if you get a boat or you're on some boat that you're driving, you would recommend like doing that, or I mean, you could usually rely on the electronics, right? Like, or how involved is it to prepare those?
So that is a good question. And I want to like ask the class for more feedback on doing a deviation table on a recreational boat. For me in the commercial industry, we would hire someone to come on board and create one for us. You can make one. You can hopefully, since the last time the boat was in shipyard, they did one, so it might be, you know, like 5 years old or older, who knows. And you could, you know, test it out, see, you know, get a couple bearings and see if the old one is accurate. But I want to say I'm sure there's, you know, companies out there that can do them for you if you want one done. If you're chartering a vessel, I'm sure the charter would have to have it.
Yeah, that's the kind of thing I was thinking of, if you're renting or chartering or whatever. Okay.
Yeah.
Interesting.
But yeah, I would love to get feedback on people's experience with deviation tables on board on recreational boats. I don't know. I guess my long answer is I'm not exactly positive, but yeah.
That's fine, thanks.
All right.
Thought that whole table, like going through the homework assignments, it was interesting to just have this table available and
yeah,
we'll just plug the numbers in.
So I want to say you should have one on board, but
right. Yeah,
is that realistic? I don't know.
Yeah. Okay.
All right. Well, let's get started. Tonight we're going to go over our LOPs, different lines of position, and getting fixes. So, and we're going to review our dead reckoning. So we're going to put together those compass bearings and headings and compass error, along with our 60D street that we are all now masters of, and get our fixes and see what it looks like. So we're going to do a little PowerPoint presentation. It's not too long, and then we'll do assignment assignment 11 together. Yeah. And tonight is going to be my last class. You still have 2 more after this with Robert. He's gonna take over for me. Next week will be the bow and beam fix and running fix. So just some more detailed types of fixes. And then the last week is typically when we do this class in person, it's kind of a review of the final assignment, and we can do that together. But I have a video tutorial on the Google Classroom YouTube of that final assignment. So you can, do it on your own and follow along, rewind, go back, however you want to do it. So the last class is kind of designated to whatever you guys want to talk about. If you have a specific topic in mind. I think Robert can also go over different classes at OCC, and I know he teaches some other ones. So just kind of think about if you have a specific topic in mind to go over on the last week of class. But other than that, it is kind of just a review of the final assignment, which there is a tutorial for. So check that out. Robert said he'll be emailing a new link to a new meeting. So for next week,
I went in on YouTube and it still don't have no volume.
For next week, it won't be this meeting link. It'll be a new one. So be looking in your emails email from Robert for that. What else? I wanted to say one more thing.
Sign up for the CoNav1 class.
Yes, CoNav1. So yes, we are going to be offering CoNav1 after this class, which then focuses on set and drift and tides and current and that kind of thing. So if you want to dive in deeper to those topics, it's just a 4-week class. So it's not as long, but another great addition to this one. So feel free to sign up for those. And I've also just had students retake it, in the fall when we teach again. You can retake the whole CoNav1, CoNav2, and I feel like the second time around students take it, they learn a whole lot more because it's not all brand new information, and they can get through the plotting a little bit. So that's always an option too. Just throwing it out there. But for that, that's all I got for announcements. If you guys don't have any questions, we'll get started. So let me share. I'll bring up my chat. Okay, so we're doing DRs, LOPs, and fixes tonight. And we'll get into what all of those fun acronyms mean. But first, my maternity photos came in, so I get to show you a little picture of little baby Bennett and my dog and my husband. But yeah, let's start talking about dead reckoning. So why do this pop quiz from last week, why do we use dead reckoning? Anybody? Because it's just a calculated position, right? We're just calculating and making assumptions that this is the actual course that we're doing, this is the actual speed that we're doing, and we're just calculating this position, making a lot of assumptions. So why do we do this? Okay.
I think it's another point of information. It's another point of data. It's a place to start, or it's another tool.
It's another tool. Yes, another tool in your toolbox. And I like that it's a place to start. That if you don't have anything else in your toolbox, it's someplace that you could say, hey, I don't have any other information, but I think I could be here. So it is just a calculated position. We do want to, you know, have that in our minds when we look at a DR, because again, we're assuming a lot. But if we don't have our GPS is knocked out, we don't have electronic navigation, there's no aids to navigation around us, so we can't get any bearings, you know, we're in open water, then we need to have, you know, a guess of where we are, and we could make those assumptions and say, well, if I've been traveling at roughly 5 knots, we're roughly 2 hours, I'm roughly, you know, heading due west, this is my position or whatever. So it gives you a good starting point. Some people call it like a position area that maybe you are. But it also, which I think in more practical purposes, it is great for those predictions, intentions, or projections. So really projecting out what's going to happen in the next hour. You know, what do I need to be aware of? Am I going to be crossing a traffic lane? Am I going to be, you know, coming up on the entrance to a major channel, or, you know, a ferry crossing, or a yacht club, and there's going to be a lot of small boats around or something. So what's going to be happening specifically in the next hour, the next 30 minutes, that projection ahead to say, oh, I'm going to have to make a turn in 15 minutes. I need to be thinking about what my next heading is, you know, my turn, or making those predictions ahead of time so that we can plan, right? Navigation is all about preparation and planning. So, so we want to know where we were, and then going forward, what our prediction or projection is. So dead reckoning, DR, we start with our known position. So we have to start with something, whether it be 5 minutes ago or whether it be 3 days ago. You have to start with a known position. And then you have an assumed course and assumed speed, whatever you, you think you're doing. Okay. So when do we plot a new DR position? So we want to get into the habit of putting one, I like to say, on the top of the hour, every hour. The book says every 30 minutes. So that's why I have this in here. But at the top of the hour, or, you know, on the 30, it makes it a lot easier to make those estimated eyeball, you know, like, oh, I am going to be passing the Huntington Beach Pier at about, you know, 7:45 or something, because you're somewhere in between 7:30 and 8, or 7 and 8, but closer to 8. It's just easier to make those guesses, or I would say educated ETAs, when you have it on the top of the hour. And I think we'll get into an example today that I'll go over for that one. But yes, so every hour or 30 minutes, and at every waypoint or turn. And then you want to replot a DR if you change your course or your speed at any point. So again, your course and your speed are the two things that you're assuming to create that vector. So if one of those change, then we need to change our DR position. So if we slow down for some reason, or you know, there's vessel traffic in the area, so we made a course change, or we slowed down or sped up, whatever it is, we want to update our DR. And then, let's see, anytime that we actually get a new position, so, you know, we start with that known position. So anytime that we actually fix our position or we pass close to an aid to navigation, we can do a new DR. So anytime we actually get a position, you do a new DR. So hopefully it will get quick and we can do our DRs pretty quickly. Okay, any questions on dead reckoning? I know we practiced a little bit last week, but any questions? Okay. Okay, so now we're going to talk about an LOP, a line of position. So basic definition for line of position is infinite possibilities along this line. This line can be any shape, and it could be any, infinite possibilities, literally anywhere along that line. It's just one piece of information. So I'll just go into our examples instead of asking you to tell me. So some examples. I would say the most common that we're going to see or use in this class, maybe you use out there, is a visual sight. So if you are on your boat and you see a lighthouse bearing a certain degrees, that is a visual sight, that you see something from your boat bearing this data number, this 090, this whatever value. And that's the piece of information that you use to say you are somewhere along that line. And I'm going to go into an example of that, but we're just going to kind of list some brief examples here. If you have a radar on board or another electronic means, like some electronic plotters might be able to do range and bearings as well. So a range would be a distance. So you can measure using your radar or sometimes your electronic plotter. Oh, I'm 2 miles away from that buoy or that point of land or something, that you could make that a line of position. So a distance, you can make a line of position, and we call that a range. A electronic bearing is pretty similar to the visual sight, but using your electronic means. So using the electronics to say, yes, that point of land is bearing such and such degrees, instead of seeing it with your eyes and using a compass. So you have the electronic range and bearing, the visual bearing, and then you have a visual range. And this one I always like to say is my favorite, because you don't actually need a tool in place. You can just see two things with your eyes, and you don't even need to measure, use a compass or anything. You can just see two things in line. And again, I'm going to go over that one. Loran C, we don't use those anymore, but again, they're on the training charts, and those are lines of position. Our distance off calculations, and that's what we're going to go over next week, is our bow and beam. Those are lines of position that we can use. Our celestial sightings. So just like visual sightings, if we had a compass or something and we measured, we can see that lighthouse at 090. You can do that with celestial sightings. We can see, the sun bearing a certain degrees at a certain height. And that gives us the same kind of line of position. And then lastly, I have listed our contour lines or our fathom curves. And I'll show you an example of those as well. So let's get through. I would say most common is going to be our visual sight And a visual sight and a range is one of the most, a bearing and range is one of the most common ways to get a fix, a quick fix from one object. And I would say they're all pretty much straight lines, except for the ones in blue here. Our radar range is not going to be a straight line. It's going to be an arc, and I'll show you that. And then our visual range is going to be a straight line, but I'll show you that. And our contour line is going to be a curvy line. But let's get into some examples. Okay, so yeah, our first type is getting that visual range. So you can use, typically for recreational boaters, we're going to be using that handheld compass. Again, I don't have any for you to play with in class right now, but some have that pedestal and some are flat. You can get them at, West Marine or Amazon. And you're using this compass to line up, on this type, you want to line up the two things, two little visual sights, I would say, in line with the object that you are looking at. And then you want to write down that number and note the time so that that data piece has a time, a value on the compass, and then, the location. It's Lighthouse A at 0700 bearing 210 degrees. So it has that data information, but all you're doing is measuring the bearing. On bigger boats, we have, if you have like a mounted compass, typically, it's the same type of thing. You have two little lines that you're lining up. You're looking through, one, and you see the thread of another thing. You line them up and you see what it reads on the compass. So if you have a mounted compass on board, you can use that. And that's typically, I would say, when the questions in the homework, or if you're taking a Coast Guard exam, are referring to getting a bearing in this way. When it says specifically a handheld compass, and that's typically probably what you'll be doing on board. It's getting, it's using one of these handheld compasses. So we have the ship's standard compass, steering compass, whatever you want to call it, and the handheld compass. But both you can get a bearing off of. So you're literally just lining these two things up with what point of land or buoy or some sort of object and reading the value. So then when you draw the value, you're drawing a line on the chart. So we'll just take an example here. This vertical line. So it has a bearing of 180. So if there's a boat right here, long point could be bearing 180, but you have an infinite possibility. You can be here, infinite possibilities along that line with just that piece of information that says at 0700, I got a bearing to long point and it was bearing 180. So I draw my 180 line to long point, and I could be anywhere along that line. So this can be, I guess I want you to visualize in your heads that it's from you on the boat to the object is your bearing. So a lot of times when we draw this, we don't have that where we are. So we're drawing it from long point in the direction of, due north, essentially, because we're infinite possibilities that we're on this line with long point bearing to the south of us. Does that make sense? So we're on the boat and the bearing is towards the object, but we don't have that starting point when we're drawing the line. So we're drawing it kind of the reciprocal, if you're thinking about it. So you always want to, if you have like, typically on our, homework assignments and stuff, we have no idea, right, where this object is or where we are. Hopefully, if we're cruising along, we have a general idea of, oh yeah, I'm, west of Catalina or something. I know where my line's going to be. It's going to be a lot easier to draw. But sometimes on these homework assignments or on the tests, we have no idea where we are. So it's like you're drawing yourself on the other side of the island or something. Anyways. So again, infinite possibilities along these lines. So, this boat over here for long point would be bearing 255. So if we kind of go into that, which quadrant of the compass am I looking at, right? If something was bearing 0 to 90, it would be, northeast of us. Was southeast, it would be 90 to 180, but it's in the 180 to 270 range, so it's going to be somewhere to the southwest of us. So you guys can kind of think about that quadrant of the compass kind of thing. But yes, infinite possibilities, I guess, is what I've said a million times right now. Okay. So we also want to keep in mind that, we've said it before, our bearings can be different than our headings. We don't want to get those confused. So our heading can be one way and our bearings can be a different direction. So keep in mind that they're different. Okay, so that was bearing. So when we have it on the chart, we have a straight line labeled with a time that says 8:35. This tank was, my bearing line from this tank, I'm somewhere along here at 8:35. If we have a range, this is a visual range. It's when you have two things in line. So here's another visual range example. They have a stack and a tower. It could be just a point of land. It could be just two things in line. It could be a point of land and a buoy, or when two things get real in line with each other. So typically you have a higher one and a lower one. When they're in line, you can draw a line connecting those two dots and say that you are somewhere along that line. So a very quick and great way to get a line of position. Now, a lot of channels or entrances, I don't think Newport has one, but a lot of, I don't know, I'd say maybe bigger ones, I don't know, have these range markers in place so that you can line up those lights or line up those range markers to make sure you're in the middle of the channel. So they're designed, as an aid to navigation to give you that LOP right in the middle of the channel where you want to be. And again, you could also look at them astern of you as you're leaving the channel. They're, I guess, built to be dead ahead of you or dead astern of you to keep them in line, but they can work as you don't have to have them dead ahead of you or anything. Anyways, so that is a visual range. Here's another example. So this is Dana Point down here, and we have 2 aid to navigations. So 2 charted aid to navigations, a buoy right off Dana Point, and then we have a yellow buoy maybe a mile or 2 out. If we see those in line with each other as we are cruising along, we see those 2 buoys come in line, we can draw a line connecting those 2 buoys and say we are somewhere along that line. We could be right next to the buoy, we can be another 5 miles out, infinite possibilities again, a line of position, but we are somewhere along those lines when we see those 2 things lined up with one another. So if we are somewhere to the south of this line, those 2 things are not going to be lined up with one another, right? We're going to see one to the right or one to the left. And vice versa if we are to the north. So it's also good if, which I think we're going to talk about this week or next week. Next week maybe danger bearings, where if we have something, you know, to the right and to the left, I always want to keep it to the right or to the left if I want to maintain staying to the north of it, instead of the opposite. But we can go into that later. So that is a visual range. The key to a visual range is 2 things in line with each other. Those 2 things have to be on the chart. So it can't be the cruise ship at anchor and the buoy. That cruise ship at anchor is not on the chart. But it can be a point of land. So it can be, you know, Long Point or the end of Catalina or something, some curve of the land and an object. But that is a visual range. And again, we just mark it on the chart as a line. Does anybody have any questions on a visual range? Excuse me. Okay, so now let's talk about the other type of range, which is our distance range. Here we go. Distance range. So typically I would say the only way to get a distance range is by having a radar on board. And you can create this, it's called a variable range marker, or maybe you have a cursor depending on what type of radar you have. If it's just a small basic radar, you might just have this green variable range marker where it might be a knob, and so you could turn this knob and it creates this distance scale where you can say how far away things are. So in this case, I'm lining something up. I'm lining my green circle up to see the very distance of this point of land. So if I say, okay, this point of land is 2 miles away, I can go to my chart and see that point of land, and I could put that distance on it and create an arc. Oops. So say I had it 2 miles away. From that arc, or from that point of land, when I create my arc, it's going to be 2 miles away. So this can be confusing, as you can see. The circle goes kind of the opposite way, if you will. But when we just look at that data point of I am 2 miles away from this point of land, then when I draw an arc, I get my measurement of 2 miles, and I can draw it the whole, you know, as much as I can. And all I'm saying is that, you know, at 0700, I am 2 miles away from this point of land. Infinite possibilities along this arc. So this line of position is a arc or circle, if you will. So I could be anywhere along this line. I don't have a specific place because I don't have a bearing. All I have is a distance. So all I can say is I'm somewhere along this line 2 miles away from this position. So when we draw it on the chart, it can look like that. So we have a time. You could put the distance, you don't have to, but you have a time and you can say I'm somewhere along this line, and it is a distance arc. So that's another line of position. Does that make sense? Okay. So a great tool is to get a range and bearing to a single aid to navigation or single point on your chart. So one light here has a bearing and a range so that I can get 2 lines of position using one aid to navigation. So I have a distance and a bearing. And when we get 2 lines of position, that is called a fix, which we are going to dive into. But that bearing and a range are great, is a very common, quick way to get a fix. Okay, the last, I'm going to go back to my four types of LOPs here. We have that visual range, we had the visual bearing, we had a distance arc, and the last one is called a tangent bearing. So a tangent bearing is again using electronic navigation, probably your radar. So electronic bearing, again, you have your VRM, that's your variable range marker. So that's that knob that we can turn to see, the distance away from an object. We also have another knob called electronic bearing line, which gives us a bearing to an object. Now, a radar has more accurate range distances than it does bearings, but we can use the bearings as well. But just throwing that out there, it's more accurate in range than it is in bearings. But we can move this knob or this line kind of around the scope, if you will, to get it tangent in line with a piece of land. So definition of tangent means that our line passes through a circle or an arc at just one single spot. So this green line passes through the arc at one single spot. The red line does not pass through the arc at all. This red line passes through it twice. So at that very point where it only passes through a circle once, a line passes through a circle. When it only touches, barely touches that circle in just one single spot, that is called a tangent bearing. So it's not touching it, and it's not touching it in 2 spots. So it's that very tangent spot, I guess. So if we look at that on the radar, we're going to look at the same kind of thing where we have our green tangent bearing. If we had it not touching, and this is to this point of land right here. So if we had it not touching the point of land at all, it would be, to the north. If it's touching the point of land in 2 spots, it would be to the south. So we put that tangent EBL just at the point where it just touches the point of land at one spot. So that's what's called a tangent bearing. So when we draw this on the chart, I guess I don't have an example. Let's show you. Got it. So we have a curve of land. Here's my radar scope. And I have it touching the point of land in just one single spot, right? So it's not touching in two areas or not touching at all. It's just that one single spot bearing, I guess I'm going to say 090. So when we have this on the chart, I can just get my 090 line. I'm measuring 090. And whenever that 090 line just touches, of course, this isn't going to work. Let's use this one. Whenever, I read from my compass, here's 090. Whenever it just barely touches this point of land, then I can draw my LOP and say I'm somewhere along here at 0700. So you get the bearing, whatever bearing it is, the tangent bearing, and then you just barely touch the land on your chart and you can draw in your tangent bearing. Okay, so let's go back to the PowerPoint. Okay, so those were our 4 types of bearings. Does anybody have any questions on those 4? All right, hopefully it makes sense. Last one I'm going to talk about is what they didn't have on that paper, is our contour lines, which I think are great, quick and easy lines of position to use, and they're pretty underutilized. So as you are approaching a certain harbor, here's an example of 2 harbors here, the isthmus. Typically, the water is going to be getting shallower and shallower as you make an approach to a specific harbor. So that change can be very significant. And if you have a depth sounder or Doppler, some sort of instrument on board to measure the depth or the water under your keel, whatever you want to call it, under keel clearance, you have some sort of tool on board that measures, what the water depth is, then you can use these lines that are already marked on the chart for you as a line of position. So if you're making your approach and you say, oh, I just saw, at 0840, that's the time, 0840, I just passed the 200 fathom curve on my depth sounder. I can say I'm somewhere along this 200 fathom curve that's already on the chart. And maybe if I'm following a range in, I've already drawn the range line and I can just quickly mark that's where I am at 0840 time or whatever it is. So as you are making this approach, I'm looking to mark the time when I pass the 100 fathom curve. I can see on my depth sounder, it's getting shallower and shallower past the 100 fathom curve. I must be somewhere along this line because this is the 100 fathom curve. So infinite possibilities. Again, it's just a line of position, but it's already marked on the chart for you. So I like to go with, looking at the chart and seeing what fathom curves are on the chart, and then looking for that and marking that time whenever it happens. So instead of saying, oh, it's 179 feet deep right now, this is where I am, because we don't have a 179, fathom curve, I would use one that is already marked on the chart. Go for your 50, your 100, 150, etc. Does that make sense? All right. Okay, so those are our lines of position. Let's go back to the beginning. We did visual, radar range, radar bearing, visual range, Loran-C is not used anymore. Distance off, we're going to go over next week. Celestial, again, it's just that same kind of using, a bearing basically to a celestial body. And then we have our contour lines. So lots of possible, lines of position out there. That sometimes if you only have, one option, you got to get creative to find another option to get that fix. Any questions about lines of position, or anybody use a different line of position that I haven't mentioned? Okay. Then let's dive into a fix. Okay, so a fix is going to be an exact position or an exact point. So that LOP was an infinite possibilities along the line, where a fix is an exact point, a single point on the chart, or an exact position of where we are. And how we get this fix is by getting two or more the better, lines of position. So if I have an infinite possibility along this line and an infinite possibility along this line, wherever they meet or they cross, that is a fix. So if at a specific time I could be anywhere on this line and anywhere on this line, I have to be where they meet or where they touch. And that is what we call a fix. So the basic things you need is two lines of position. So it can be, any of those types of lines of position that we just went over. And I would say the third or the fourth help prove that the first two that you took are correct. So the more lines of position you have, I would say the more accurate your fix will be. But again, these lines of position have to be taken or observed. Do I say this in the next one? Anyways, they have to be observed simultaneously at the same time. So this fix gives us a position of where we are at a specific time. So at 1920, we are right here. So both of those lines of position that we have to be taken at 9:20. So it has to be a quick, range and bearing, or two visual bearings done, as simultaneously as you can get. So like get one and then get the other, but don't take, 15 minutes in between. That's what we're going to call a running fix, which we'll do next week. But our basic fix is going to be two or more LOPs at the exact same time. Now, to note, when we're drawing this, our DR track line is not an LOP. So even though we might have a third line drawn on the chart, because we said, this was our position, an hour ago, and this is my course, let me go to my whiteboard. Okay, so I had right here in 1920, and I am headed in this direction. At, let's say at 2000, I have a buoy over here and a light over there, and I get two LOPs. I get a bearing, I'm somewhere along this line, and I'm somewhere along this line. So, you know, I actually measured that. When I create my position, I am saying I can only use an LOP. So this is an LOP because it's to a object that I got a bearing from. And this is an LOP. So this would be my position. I can't use my predicted, you know, oh, I'm headed at 0:45 degrees. That is not a LOP. That is just the course that I was using to say, I think I'm going to be here at 2000. And then when I actually got a data or information, I found out I was someplace else. So we want to be careful because when we're drawing on our chart, you know, they're not color coded like this. You know, they're just pencil lines, and those pencil lines can, you know, the more and more pencil lines we get on our chart, it can get more and more confusing. So labeling and being specific is always a good thing, I guess, which we'll get into how to label them and things. So let's go back to the PowerPoint.
So I have a quick question, I guess.
Yes.
Maybe it goes without saying. So now that you have this updated fix, do you want to reset your course somehow to, you know, stay back on your heading that, or your destination? So now if in other words, if you stayed on the same course or the same magnetic heading or whatever, you're going to miss your destination.
Correct.
You're off track. You're off track here, in other words.
Yes, we are off track in this example. I'm literally just made this up, but
Yeah, right. But it's, I think,
yes,
a good demonstration of
so
why you need to do these.
The question to the navigator is, are you just going to keep your course, or do you have a, you know, a destination in mind that you want to change your course to? So do you want to go just back to the track line, or do you want to go directly to your destination? That's up to the navigator. You know, sometimes you just want to cruise on back to your track line and then maintain your course, or you change and say, okay, this is my new course line, and, you know, this is my new DR for 2030. So anytime we do get a fix, we replot our DR. So do we want that DR to be on a new track line, or do we want to adjust course to just go back to our already plotted track line? That is completely up to the navigator. I would say recreational boating, you really don't care to go back to the track line. You can just keep on heading for your destination. Maybe if you're in a traffic lane, you want to go back. So you just kind of merge, you know, alter course to back to the left 2 or 3 degrees. and you eventually get back to track. Maybe you plot another position, you're right here, plot another one, then you're on track, plot another one, and your positions kind of look like that, kind of weaving back and forth on a track line, which is, you know, completely acceptable. Or you just completely change your track line. So again, that's just up to you on your boat. Okay. Okay. So how do we draw effects, our steps? Our first one is to observe the direction of an object. So this is getting a bearing. We observe this light bearing, I don't know, 330. And then we're going to draw the line on the chart and label it with time. So again, that 330 is from us towards the object. So when you're drawing it, you don't have that starting point of where you are. You're kind of drawing the reciprocal. I like to, sometimes I don't even draw, you know, this whole line. I would say as a beginner, it would be good to just draw a dashed line and then kind of your solid line in the general area, you know where you are. So hopefully, you know, oh, I'm about, you know, 5 miles off the coast. I don't have to draw this big long line. I can just do light dashed line or not even, and just draw a line in my general vicinity. And then we label that line with the time. So at 0900, I'm somewhere along this line. And then that's one LOP. And then you get another one, and wherever they cross is where you are. Now we're going to talk about choosing your objects. Couple factors. First one is the objects must appear on the chart. So it can't be, I guess I can't say it can't be, but you know, sometimes our personal landmarks are not the landmarks that are on the chart. So, you know, that bright pink hotel or, you know, the big crane or something that is really easy to see and you always know that's where we're going to turn, or that's a great thing to see with my compass. If it's not actually on the chart, then we have nothing to mark a line of position from. So we want to look on the chart to see what landmarks are, you know, on the coast or what aids to navigation are out there, and then look visually for those specific objects. So we're looking specifically for objects that are already marked on the chart. So it can't be that, you know, street light or construction crane, pink hotel. Sometimes, you know, the Hoag Hospital, that one's marked on the chart. The Huntington Beach PowerPoint stacks, you know, there are landmarks on the chart, but not every single building on the land is on the chart. So you want to look specifically for those that are already marked on the chart and use those as your visual bearings. The second thing we want to talk about is the spread, I guess, widely spread bearings. If you have bearings that are very close together, your accuracy can go down. So if you have two bearings, as the top example shows, we have an almost 90-degree cross, and that's going to be our most accurate for 2 LOPs. If we have 3 LOPs and they're all on one side of us, like one side of the boat, we want them approximately 60 degrees apart, but no less than 30. If they are on all sides of the boat, we can do 120 degrees. And that's the bottom example. Let me go to my whiteboard again. So this is saying, you know, if we have an object here and an object, maybe we have an object here. If I'm cruising along over here and I get an LOP to this guy and an LOP to this guy, if this is less than 30 degrees, it's not, I could be, you know, a small change in this line or a small change in this line could really give us that, you know, possible position having a much greater area. We could say we're kind of anywhere in this area. If these were more spread out, I would, my accuracy on, you know, give myself a little wiggle room because I know I'm new at this. My accuracy might be this general area, a little bit tighter than if these two buoys were very close to each other. So it's just the geometry. So it's just, yeah, the geometry of it that you have better accuracy the further spread out your aids to navigation will be. And then my last, or I guess, oops. My last one on here is which one is changing faster? So again, with these visual fixes, we want to do them simultaneously or as quickly as together as possible. So again, that can be hard as we're moving from one side of the boat to the other side and we're trying to find you know, this plotted object on the chart and then get a visual fix from it. So the ones that are changing faster, I would say you want to, you know, get first, and those would be, I guess, depending on how you're plotting it, more or less accurate. So the bearings, when they're on your beam-ish, those are changing quicker than objects that are on your bow or on your stern. So as you are approaching an object, the bearing towards it isn't changing rapidly, right? It might be changing as you are making your approach, you know, somewhere objects on the bow, but it's not changing as rapidly as an object that is closer to the beam. Those bearings are changing much more rapidly. Does that make sense? When you're kind of thinking about how your bearings are changing as you're moving through the water. Something to think about when you are trying to get your simultaneous objects. Now, in reality, you know, I guess not in reality, ideally, in this class, we're going to try to do fixes where we call them pinwheels, and all three of our LOPs line up and meet perfectly. That's called a pinwheel. Where in reality, we're not going to get all three of our lines or four of our lines, however many we have, to cross exactly at the same spot. That we create this kind of triangle. So that triangle is kind of that triangle of, possibilities. We can be anywhere in that triangle, but then we use that extra information that we have of, this bearing was changing much quicker than this one, or, I was really wobbly. I wasn't sure if I was looking at the exact buoy that I had on this one. You could kind of put weight, if you will, on, or, weight of importance or accuracy on your lines that you're plotting. So you could say, I think I'm going to be closer to, these two red ones than the blue ones. So I might say my position is a little bit closer over here. So this is where, that art of navigation, where you get to, put in your information and say, hey, I might be right in the middle, but I kind of think I'm going to be a little bit closer to this corner of the triangle or something. I will say though, if there is a danger or, shoals, rocks, whatever it is, if there is something on the chart, you always want to just assume that you are at the closest possible point to that danger. So if there is rocks on the chart, we don't want to be like, oh, I'm just going to assume I'm on the furthest away line and call myself safe. You want to assume that you are closest to the danger and make your changes or maneuvers accordingly. So kind of, assume the worst and then, err on the side of safety. So hopefully that makes sense. Any questions on the fix? Okay. Let's take a 10-minute break here. Let's come back at 7:45. Let's stop share here. So back at 7. That's not a 10-minute break. 7:50? Yeah, 7:50. Come back at 7:50 and we are going to start working on assignment 11, which is going to be on the training chart. So I will get my training chart set up and we're going to start practicing plotting these lines of position and fixes on the chart. So I can think about some questions, but let's come back at 7:50. Okay. All right, any questions before we get started again?
Could you go over again why or what the effect is of getting the bearing on the point that's moving fastest first?
Yes. So, here's my book. Here's light. Say watermark. Here we have a couple buoys or something. Okay, so as we are making an approach to a channel, typically the things, ahead of you, kind of, if this is our boat here, are going to be changing less quickly than things on our beams. So as we're making this approach, our safe watermark over here is going to change. The bearings can change much more quickly than the bearing to something ahead of us. So it doesn't have to be directly ahead of us, just kind of in that general area. There's going to be less change. So if I'm trying to get my, 0800 fixed, and 0800, I'm going to say, okay, this is my bearing for this one. Maybe I got this bearing at 082, 0802 or something, but I'll just call it 0800 because I know that it didn't change as much in those 2 minutes as one that's closer to the beam. So I'm just going to call this 0800, and where these two meet, that's my fix.
Yeah, okay. So if you took the other one, what would you call it, the safe watermark? If you took that one first at 0800, then by 0802, when you took the one on the land, that you'd be much further off from the first one after 2 minutes. Yeah, there's a higher rate of change there. Okay.
So you want to, get these as close to the same exact time as possible, but in reality, you might not be able to do that, right? So maybe you got this one at, 7:59, and that one at 8:02, you can call this fix 0800 because you're closer to the one that's changing faster.
Okay.
Because this one has less of a change in that amount of time.
Right.
Bree, can you kind of go over, you don't have a handheld device. So you're using the boat to take these lines of position.
Okay. So if you don't have a handheld compass.
So you use, line up 2 winches or, anyway.
So if you don't have a handheld compass, and you don't have like a mounted compass on board that you could take an object off of.
Assume you don't.
I would get a bearing by changing the heading.
Okay.
So I would line up so that this object would be dead ahead.
Okay.
And so your heading is equal to your bearing in this case.
Okay.
And then it might take you, another 10, 15 minutes or something to change course and line up on another object.
Which, I was thinking that you got to move the boat around, and then all of a sudden now you're where you are is off.
Correct. Yes. So the more, course changes and speed changes you do in the amount of time, the further off you're going to be. So if you don't have any sort of tool on board to get a bearing from, let's do this again.
And what about you're right there now you've got that light, right straight off your bow. Now you get a beam of that ATON there. Can you line up 2 winches and
yes.
2 winches and
yes, absolutely. Absolutely. You can say that one's on my beam and we are good to go. And we're going to do that next week, where things on the beam, when you line up, the aft side of your house or 2 winches or whatever you have on board, you can use a tool to just quickly plot a beam LOP. And it's a great LOP to use, except for it it has that missing, we didn't actually use a tool to get that. We just kind of went, it's on our beam.
Right.
So depending on how fast we're moving or how accurate we think we are with our eyeball, it's on the beam. That can all come into play of how accurate your position is.
Okay.
It's way better than just being like, I'm somewhere in the Pacific, so there's this kind of weight that you put on each LOP that you're getting of, how confident am I in using my compass? How confident am I in how I lined that up? If I'm eyeballing something, is it electronic? Am I getting this from electronic tool? Is that electronic tool calibrated? Is that accurate? There's all this, infinite amount of information you could put into it. So that's going to be up to you as the navigator to kind of weigh and say, okay, this is how I'm going to rely on getting my position. I'm going to change my heading, or this is how I'm going to rely on getting my positions. Handheld compass or GPS or radar or whatever tool, you want to master. Yeah, so I guess if you don't have anything on board, changing the heading so your heading is your bearing would be but you pretty much can only get one LOP at that time. If you're measuring exactly or doing that,
Okay.
eyeball. Okay. Let's get to it. We are going to do assignment 11. And we're going to start down here and around this buoy. So the first thing it asks us is to describe the buoy located at 4112.70770 west. So we have a buoy, and it says R2 FLR 4 seconds whistle. And it does have this magenta coloring on it. So what do we know about this buoy? Anybody?
It's labeled number 2.
Yes, it has a number 2 on the buoy itself. So if we are looking at the buoy, what color is the buoy?
Red.
Flashing red.
Red. It's
Or
red.
The buoy itself is red. Maybe it has a case or something on it. So the buoy itself is red. It also has a number 2 on the buoy. So that's what this told us. This first part is describing the physical buoy itself. So it didn't tell us if it was like none or can or anything like that. It's just a buoy that is red in color. And it has a number 2 on it. It's also telling us, because of this magenta stamp over the light, that there is a light on the buoy. So we somehow have this light on the buoy. And this light is giving us this characteristic. So it is a flashing red every 4 seconds. So that means it flashes, and then it's empty, then it flashes, empty, flashes, empty, flashes. And the time interval in between the beginning of one flash to the beginning of the other is 4 seconds. So it flashes red every 4 seconds, and it also has a whistle on it. So this is going to help us, correctly identify which buoy we're looking at. We have, another lighted buoy up here, but this one's green. Then we have another red buoy over here, but this one has a number 4 on it. So if we are right next to a buoy, here's a white buoy, but it has a DD on it. We want to make sure we are correctly identifying which buoy we are next to. So are we next to this one, this one, this one, this one? We want to make sure that we're at the right buoy if this is our starting point. Okay. So this is our buoy. We're going to start here at 0800, and we are going to plot a DR course. We're going to start with our DR. From this buoy, let's plot our 8:30, 9, and 9:30 DR positions if I'm on a course of 294 at 6.3 knots. So I'm going to find 294 on my triangle. I'll do it with the roll plotter as well. I'm going to start
Magnetic
with
or true?
true. So I'm going to put my pencil on the buoy, and I'm going to find 294. So I have my pencil on the buoy. Let's zoom in a little bit. Okay, so I'm using the vertical line. So here's a vertical line, a line of longitude. And I'm putting my focal point on the vertical line. And then on the edge of the triangle, I'm finding 294. So here is 290. Here's 300. So I'm finding 294. So focal point on the line and 294. And that is my angle, my 294 angle. So I'm going to draw in my line. And I know I'm going to be cruising on this line for a while. So I'm going to extend it out. Again, I'm gonna draw my line using the same triangle, so it's the same line. That's good enough. Okay. So this is a course of 294 degrees true at a speed of 6.3 knots. And I want to plot my 8:30, 9, and 9:30 DRs. So if I have a speed of 6.3 knots, and this is my 8, I want my position every 30 minutes. So my time is going to be 30 minutes. What is my distance?
3.5.
So we use our 60 D street. We're looking for distance, so we want that D by itself. So we get D equals S times T divided by 60. So we get 6.3 times 30 divided by 60. And Barbara, you said it, what was our?
Well, it doesn't mean it's right. I got 3.5.
3.15.
1.5, okay. What did I do? Where's my math?
Also do the
My phone calculator.
magic circle. We have 60 DST. If we plug in our values, we have 60.
Oh, you're right. 0.1.
3 and 30. So we're going to multiply these two and then divide by 60. Make it 3.15.
Well, that's not good. I'm all messed up then. I'm all messed up.
Okay, so I'm going to use my, got to find 3.15 miles using my dividers here. Let's see, look over. There we go, we can see that. 15, 1, 2, 3, 3.15. Okay, so I'm going to use this and mark on my line. That's 8:30 every 30 minutes. That's 9. That's 9:30. And I'll do a 10. What the heck?
Oh, wait.
So I'll put, this is my 0830. This is my 0900. 0930. And my 10. So these are my not estimated position, but my DRs, my calculated positions of where I think I will be. Just by using my course and my speed. Okay. Now it asks us, so that's, or no, number 2 is what is the position for our 0900 what is the Latin long for 0900 DR position? So I want to find my 0900 DR position, what the exact, so this is just a practice in plotting Latin long. Like there's not really a practical reason why we would need that position, but just a practice in plotting what your latitude is and what your longitude is. Okay. Then it also asks us, is there a potential problem if we stay on this course? So I have done a poor job of doing this, but anytime you draw your track line, you do want to look around that track line and see if there's any potential problems or just potential things to mentally note. So we have deep water, we're passing this shoal, but it's still pretty deep, 52 feet looks like the shallow part of the shoal, still very deep. We do have right next to the track line here an unexploded depth charge. So it was estimated date was last observed there in 1957. So is it really a threat? Probably not. But we are going to treat it like it was an object that we do not want to pass over. So maybe around 9, we'll have to change our course, or 9:30, to avoid this specific object that we want to avoid. There is a buoy right here as well, so we could note, as I'm cruising along, once I pass this buoy, a beam, after that is when I have this potential risk that I'll be aware of. So if that buoy is still ahead of me, I haven't reached that potential threat yet. So let's go back to the beginning here. We do another exercise of plotting what this Latin long is. Let's do it a different way. Let's do it with the roll plotter. So I have a roll plotter. I want to put in my longitude, line it up with a line of longitude, bring it over. And I can also mark it down here. Latitude. And then I can measure what my latitude is by seeing the distance from my marked latitude to the one I just put in, bringing it all the way over and reading the latitude. Same for longitude. See what this distance is and bring it all the way down to read what my longitude is. This is just an exercise in plotting your Latin long. You can erase the lines that you make on your chart just so you avoid getting too many lines everywhere. Can get confusing, so there's that. Okay, so now do we get to a fix? Yes. Okay, so we want to fix our position soon so that we don't get into trouble with this depth charge. So at 9:15, I'm assuming I'm going to be somewhere in between 9 and 9:30. So I think I'm somewhere in the middle, somewhere along here. At 9:15, I observe gay head light. So that's going to be this light right here. And it gives us this big long description. And I'm also going to see buzzard's light, which is up here. I have marked a bunch of stuff on. Let's try to erase that. So here's our buzzard's light, and this is our gay head light. So from me at 9:15, those are pretty good spread. You know, maybe not quite 90 degrees, but greater than 30. If I were to get a third LOP, what buoy do you think we should do, or object? Maybe we can get one off of the island over here, or if I can still see a buoy. Sometimes the buoys are harder to see. Lights tend to have a further distance visually. But maybe I could see the land, or I have a radar or something. That might be a good spread. But if I get, you know, a bearing to buzzards from my 9:30 and a bearing to this buoy, from this buoy, this close one that I could see, that might not be a good spread. We're not going to get a good cross there. So I'm going to go with, we're going to go with these two. They're the ones that we have plotted. Okay, so 9:15, we observe gay head light at 050 degrees true. So I'm going to put my pencil on gay head light. And then I'm going to find 050. And my vertical line is right next to my light. So might not reach where I want it to, but we'll see how it goes. 050. All right, so can we see I have my pencil on the light, my focal point on the vertical line, and then 050 on the end of that vertical line. Okay, I moved my triangle. There it is. 050 focal point. Oh my gosh. Should use my right hand. I'm right-handed anyways. Okay, let's draw the line. I'm going to get crazy. My line can't quite reach, so I will extend it out so that it crosses my general vicinity of somewhere of my 9:15 position. So this one I could make, you know, a dashed line if you want, because I know that I'm probably not, I'm infinite possibilities along this line, you know, even if it went out across the chart. But because I have my DR track line here, I know that I'm probably somewhere in this stretch of the line, probably not that stretch of the line. So you don't even have to draw that part if you don't want to. Okay. So I have my We're going to label it with our time. It was 09:15. And I have my bearing to Gayhead somewhere along this line. And I also have a bearing to Buzzards up here at 340 degrees. So let's find 340. So I have my pencil on the light. Then I have my focal point, and I'm looking for 340, right where I have that big smudge on my triangle. Okay, so I can do dashed line, and then somewhere around my vicinity, I can make a solid line. I could also use the compass rose if I'm using a roll plotter. I could find 340, line that up. And then when it crosses my buoy, I could draw in my line. So now we have some lines on our chart. Now we want to remember that this DR track line is not an LOP. So we don't have this big triangle of possibilities. We only have 2 LOPs. So our fix is going to be right there where those 2 cross. That is our 0900 fix. So we have drifted to the north of our track line. So maybe we have this flooding current that is pushing us up Martha's Vineyard Sound.
That's 09:15, right?
09:15, you're right. Yes. Oh, 09:15. So we have drifted a little bit off of our track line. Okay, yeah, I was like, we're going to do something. It asks us, what is the position? So we want to get our lat and long. I have trouble doing that on the camera because my camera's not big enough. So you guys can look at the answers on that one. It does ask us, what is our depth? What is the depth of water at this fix? So we have 123, 131, 136, 123. And then we have that fathom curve of our 130, no, 120. So it's shallower over here, getting deeper as we go this way, 137. So I would say, here's 131, here's 136, somewhere maybe 132, anywhere between 130 and anywhere between like 125 and 135, I guess I would say is a good answer there. Yeah, you're just looking at the slopes of what the seafloor is doing.
So that's a bit of a distance from that 130 sounding line. Like I was thinking it'd be between 130 and 131, but it could be sloping kind of different directions from that line. So you kind of give it a wider range of depths. The line's 130, and then I think just to the left, isn't it 131? Just to the left of your fixed point?
Yes, 131 there. And then to the south, it's 136,
Yeah, okay, so it's somewhere in there, okay.
somewhere in there.
You really don't know exactly what the slope is, but
Yeah.
you have a pretty good
But
idea.
if your, depth sounder is reading, 100 feet, then you might want to calibrate that or check that. So I guess that's the reason, you want to plot your position, see what your depth should be, and then it's kind of a check for your instruments. Like, are my instruments, accurate? Are they reading ballpark, give or take 10, 15 feet, or am I really off? So once you get a fix, you could kind of check the accuracy of your other instruments as well. Okay. So then it says, are we on our original DR line? No, we're a good, mile off of our DR track line, which in this case isn't, the end of the world. There isn't a piece of land right here. If we're a mile off of our track line, that's probably okay. And this is where we want to make the decision. Do we want to go back to our track line, or do we want to continue our course line and just replot our DR? So that is, again, up to the navigator. What do they want to do? In this case, if we just continue our track line, we will pass our danger, our risky unexploded depth charge with much more wiggle room than we had before. So if we just continue our course, of course, if we continue, if the current is affecting us the same way, we might end up continuing to be set to the north. And we want to make sure we don't hit this buoy, our Vineyard Sound buoy. But in any case, if we don't change course, if we continue on our 294, we will be much more clear of our unexploded depth charge right there. So that is a good thing. But let's go back to our 915 and let's check to see if what we were doing, we obviously know that what we had predicted didn't happen. So let's see what did happen. What was our course made good and our speed made good from 0800 to 0915? So I'm going to connect my 0800 position, and then the next time I got a position was an hour and 15 minutes later, 9:15. So this is my made good. So I'm going to call it course made good and speed made good. You sometimes might see it as course over ground, speed over ground. It all depends on what instrument or what book you're reading. But they mean the same thing. So from 0800 to 915, what was my average course and what was my average speed? So I might not have been exactly on this line, but average, I was on this line more so than I was on this line. I got pushed to the north. So this is what was made good, and this is what I was steering. But this is, where my wake went, if you will. That's what I did over ground. So to measure the course, You know, you can use the roll plotter. I have that in my hand. I have a course made good of 302 degrees true. You could also measure it with the triangle. Triangle, I'm going to line up the line in question, put the focal point on a vertical, and read what it says on the bottom. Let's line that up. I have right about 302, 300, 310, that's 305. So right about 302, 303 maybe. So that was my course made good. And my speed made good, I have to calculate. So what was my speed made good? That's my question. So I had my time in between fixes was 8 o'clock to 9:15. And I traveled in that time a distance. Let's measure our distance. How far did I travel?
I got about 7.1.
7.1. I got 7.15-ish. Let's go 7.1. Distance is 7.1 nautical miles. Time, I need to calculate. And speed is my big question. So how many minutes do I have for my time? I have 60 minutes plus the 15 gives me 75 minutes. Of course, I can do the work there. I kind of shortcutted ourselves. 0915 minus 0800. We always put that later time on top. 15 oh yeah, 15 and 1 hour. Convert that to 75 minutes. Okay, so now we're looking for our speed. We can go to our 60 D Street. Looking for speed, so we have 60 times D divided by T gives us S. Plug in our values. 60 times 7.1 divided by 75. Or you can do the circle. The two things we have for the circle are on top. So we multiply those and then divide by 75. So what did you guys get for speed? 7.1 divided by 75 gives me a speed of 5.7 knots. So that was 60 times 7.1 divided by 75. Round into 5.7. So I thought I was doing 6.3, and I'm actually doing 5.7. So I'm going a little bit slower than I had anticipated. So we can adjust our DRs from this point. I wanted to touch, before we go on to another point, so kind of how I think Martin asked earlier, when we're at this point at 9:15, we have that option. Do we want to go back to our track line, or do we want to just hold the course? We're already in autopilot. I just don't want to change anything. So completely up to you. And, you know, sometimes you might want to go back to the track line. Sometimes you might want to just plot a new course. Completely up to you. But one of the, I guess, a trick that I use when doing electronic navigation, let's say we started at this buoy, and then I have, I'm going to call it a waypoint number 1, and then we change course and we go to waypoint 2. So my track line that I have drawn on the chart, maybe I plugged in my waypoints into my GPS. So I have this track line already plotted on the chart. I want to stay on this track line. I have, you know, gotten my 9:15 position to be a little bit to the north of my track line, right? So when I look at my GPS is typically going to give me a bearing and a range, and this is to the waypoint. Oh, it's off the screen, sorry. So my GPS unit will be usually giving me these values to bearings and range to my next waypoint. So if I'm here, my bearing to my waypoint is going to be my 294 degrees true, right? Because this was my track line, 294 degrees true. So if I am right on my track line, my bearing to my waypoint, again, this is just a fictional point that I made up and plotted. It's just a turn that I've created. It's not an actual thing. And the further I get off track, my bearing, so if I, you know, get off track here, my bearing is going to change. So my bearing to that waypoint is now, let's call it 290 degrees true. So just seeing that number change can tell me that I'm off course or off track, if you will. So if maintaining the track line is what I want to do, I want to make sure my bearing stays as close to 294 as possible. I know this is kind of like thinking outside the box, but how you do that is by seeing your GPS should also have something that says your course made good, speed made good. So if your course made good is 294 and your bearing is 294, you are on track. If your bearing gets to be 290, your course is probably looking more like 300, right? Your past course line is looking more like 300. So you want your bearing and your course made good line to be the same. You want these two as close as possible. And really, you can see the difference and use that difference to come to the right or come to the left 10 degrees. And that'll get you your 10-degree difference. So the closer these two can be, maybe they end up being, 295. The closer you'll be going directly to your waypoint or whatever you have set in your electronic navigation mode. Or you just say, this was my 915. I'm maintaining because I have something that I don't even want to hit right here anyways. I'm just going to maintain what I have going and call it good. Either way works. But I just wanted to throw those options out there. Does that make sense? Any questions about what I was kind of drawing here? Okay. Well, that is assignment 11. I think we did the whole assignment. Yeah. So, assignment number 12 is on the other chart, the Long Beach San Pedro Channel chart. And I do have that tutorial up. So I am going to call class a little early tonight. Guess we're done a little early. But I think that's all I have for you. For the homework assignment, it's a 3-day cruise. Plotting your LOPs, get a fix, and then doing DR. So it's a bunch of DRs and LOPs and DRs and LOPs, very repetitive, all around LA to Newport to Catalina and then back to LA. So that will be the homework. And then Robert's going to go over the 2 other types of fixes with you guys next week. And that's all I got for you guys. Let me know if you have any questions. I will try to get back to you, but I don't know what my life will be like in the next couple days, hopefully. But yeah, that's all I got for you guys right now.
I had some, a little feedback on the electronic navigation.
Yeah.
I don't have a lot of experience with it, but I did take a little trip out of Huntington Harbor on Sunday, and I was trying to navigate to a fishing spot.
Mhm.
And what I noticed, I think this was the little Simrad system. And so it had, it basically had course and steer to. So I started out on a certain course, but it was like constantly changing, and I was having, I think, there was some swells and, a little bit of wind, not too much wind, but I'm thinking that was just kind of kept throwing my azimuth off or something. But I was kind of going crazy. It's like, we would say, oh, your course is, your bearings 100, steer to 95. And then I kind of get close to 95 and say, now go to 110. So I think maybe it's better to kind of try and split the difference or something and not making so many corrections.
And I would say some electronic tools have like, I want to call it weather settings, but any settings either way where you can average a longer time. So especially when you have those swells, it's telling you your course made good, maybe over the last 30 seconds. But if it was telling you your course made good over the last, 2 minutes, 5 minutes, it would be a steadier number.
Yeah, I'll have to look at
So
I've got a copy of the manual and I can get.
Yeah, definitely be
but
familiar with those owner manuals so you can adjust it. So yeah, the first thing that came to my mind is your time lapse that it's averaging for you is way too small. If it's having quick changes like that and big changes, not just like 1 or 2 degrees.
And I eventually gave up and I said, well, there's 2 oil rigs right here. Let's just fish here. Try for the other one next time, I
Well,
guess.
did you get any fish?
No, but that's why they call it fishing.
Yep. Cool.
Okay, Ingrid.
So your due date is May?
Yes, next Monday.
Next
So-
Monday?
Monday, I will be 39 weeks and hopefully soon.
Almost there.
Yes, almost there.
Ready, huh?
Yes.
Yeah.
So, yeah.
Exciting. Well, we'll miss you, and
Yes.
Robert will take good care of us.
And I hope to see you guys around, the sailing center one of these days. We'll all be back in person, hopefully by the end of the year or next year. But lots of other great classes to take at OCC too. So hopefully you enjoyed this one. I know it's online and I didn't get to help you guys in person as much as I like to, but
Great.
But yeah, I think it was good.
Yeah, I actually sort of like this class being Zoom because you can, in the classroom, you don't have much room on the tables. Here, I can use my whole kitchen table to spread everything out.
Yeah.
So I like it better even on Zoom. And
Cool.
and see with your map view and everything. So works out pretty good. I was surprised. I thought it was gonna be a hard one on Zoom, but actually, yeah.
Cool.
Okay.
All right. Well,
Good luck, Bree.
Thank you.
Well,
Thank you, Bree.
Thank you guys.
Thank you, Bree.
Thank you.
Luck.
Have you?
Thanks.
Good luck. Have fun.
Thank you, Bree.
Congratulations.
Good luck, huh?
Thank you.
Okay.
Goodbye.
Bye.